Hello, my name is Emily Slater, and this is Lab 5, Choose Your Own Adventure Lab. For this lab, my model was a toy car and a ninja. My goal was to replicate the inelastic collision of a toy car and a ninja using VPython. The principles used were the momentum principle and the energy principle. The results were that the car's mass and velocity were so great that the mass and velocity of the ninja were considered negligible, and the car's motion continued as though it had not crashed into the ninja. Our assumptions were that the air resistance was negligible, there were no outside forces, no friction, and the collision was perfectly straight. We analyzed the video using Tracker and got the position data in this graph. In inelastic collision, two objects collide, stay together, and are treated as one object after that. If two objects had collided, then separated, the collision would have been considered elastic. Because there are no net forces acting on our objects, delta P will be 0. Because momentum is preserved, the momentum of object 1 plus the momentum of object 2 will be equal to the momentum of object 1 plus the momentum of object 2. Because the two objects come together and make one object, the final velocity will be equal to the momentum of object 1 times the momentum of object 2 divided by the total mass. This can be seen in the code. The initial conditions are shown here. Velocity was calculated by taking the change in position over the change in time. Energy was calculated using 1/2 mv squared and then adding both of the kinetic energy of the ninja and the car together to get the total kinetic energy. A loop shown here updates the position of the ninja and the car. The moment where the two objects collide, the position is found using the new total momentum and total mass. After running the code, we get the data to make this position versus time graph. As you can see, the two lines follow each other very closely. This seemed a little bit suspicious to me, as I did not include friction or drag, and there would be those acting on a real system. So I added a line where it predicted the motion of the car without the collision, and it turned out to be nearly identical to the two other ones. The mass of the ninja was so small that it didn't have an effect on the momentum